Hold out your hand. Imagine a single grain of sand resting on your fingertip. That grain is our solar system. Not the Earth, not the Sun, everything. The Sun, all 8 planets, Pluto, the comets at the cold dark edge, all of it, shrunk down to something you could lose in the wind. Now, keep holding that grain and ask a simple question. Where is the next one? The nearest star to our Sun is Proxima Centauri. On this scale, where our entire solar system is 1 grain of sand, the next grain isn't on your hand. It isn't in this room. It's roughly 1,000 miles away. If you were standing on a beach in Baltimore, the next grain of sand would be in Miami, and between those 2 grains, nothing. No other sand, just empty space for 1,000 miles. That is what the universe is mostly made of. Emptiness. We tend to think space is crowded. The night sky looks full, thousands of stars, scattered like spilled salt. But the truth is the opposite. Space is almost perfectly empty. If you shrank every star in our galaxy down to a grain of sand, and scattered those grains as thinly as the stars actually are, you could fit them across an entire continent, with miles between each one. The stars only look close because we are very, very far from all of them. So let's widen the lens. Forget the grain of sand. We need a bigger model. Now imagine our entire solar system is shrunk to the size of a single grain of sand once more. And the Milky Way galaxy is built from those grains. Hundreds of billions of them. On that scale, our galaxy would still be the size of a continent. Light, the fastest thing that exists, traveling at 300,000 kilometers every second, takes 100,000 years to cross it. Not 100,000 kilometers, 100,000 years. A beam of light leaving one edge of our galaxy today would not reach the other side until long after every person alive has been forgotten. And here is where it stops making sense for our scientists. Take that entire galaxy, the continent of stars, the 100,000-year crossing, and shrink the whole thing down. Make the Milky Way a single dinner plate on a table. The nearest major galaxy, Andromeda, would be another plate. How far away? About 25 feet across the room. 2 dinner plates, each holding 1 trillion stars, separated by an empty room. And those 2 plates, the Milky Way and Andromeda, are not alone. In 1995, astronomers pointed the Hubble telescope at a patch of sky so small you could cover it with a grain of sand held at arm's length. A piece of nothing, a spot they expected to be empty. They left the shutter open for 10 days. What came back was not empty. It was full of galaxies. Thousands of them. Not stars, galaxies. Each one a Milky Way, each one holding hundreds of billions of suns. In a fragment of sky the size of a grain of sand. So multiply it out. That grain-sized patch, full of thousands of galaxies, across the entire sky. The observable universe holds something like 2 trillion galaxies, each one a city of stars, each star a possible sun with possible worlds. And the whole thing, every galaxy we can see, stretches 93 billion light-years across. Which brings us finally back to the question, what's at the edge? And the answer is the strangest part of all. There is no edge. Not one we can ever reach. Because the universe is not just big, it's expanding. Every distant galaxy is racing away from us, and the farthest ones are receding faster than light can close the gap. The light from those galaxies will never arrive. They have already passed beyond the edge of anything we can ever see. Gone. Not destroyed, just gone. Forever outside our reach. So when we ask what's at the edge of the universe, we are asking a question with no answer. There is always more. More galaxies, more distance, more dark, silent, empty space, stretching outward faster than we could ever follow. They say space is the final frontier, and it never will be a 5-year mission like the Star Trek series. Because before we talk about the edge of the universe, you need to understand something. The stranger things going on and the vast scale. So the edge is not a wall. It is not a line we could fly to in any spaceship. It is not a place where space suddenly stops, like a wall. The real edge is much more unsettling than that. It is the point where the universe becomes so vast and expands so quickly that even light itself can no longer bring the answer back to us. So to understand how far away that edge really is, we have to start much smaller. Much, much smaller. Hold out your hand again. Look at that single grain. Everything you have ever known, every person, every ocean, every war, every quiet morning, happened on something smaller than that. On a speck orbiting 1 grain of sand. And out there, past the next grain 1,000 miles away, past the continent of stars, past the room where Andromeda sits on its plate, there are 2 trillion more. We are not at the center of anything. We are a grain of sand, wondering where the next one is. If you liked this video, please like and subscribe so we can make more just like this one.